Welcome to AI Frontiers, your guide to the latest in artificial intelligence research. Today, we're diving into the world of robotics with a focus on papers submitted to the Computer Science Robotics section of the arXiv preprint server on May 20, 2025. This episode, titled Robotics Renaissance: AI-Powered Autonomy, will synthesize the findings from three key papers, providing a snapshot of current advancements in the field. This presentation will provide an overview of our exploration into the frontiers of robotics. We will be unveiling recent advancements in robot learning and interaction, highlighting the transformative potential of these advancements across various industries. The discussion will also examine key findings, methodologies employed, and potential future directions of this research. To begin, let's clarify what computer science robotics encompasses. It is an interdisciplinary field merging computer science and engineering principles. The field focuses on the design, construction, and programming of intelligent robots, enabling them to perceive, reason, and act in the physical world. This is driving innovation across a multitude of sectors including manufacturing, healthcare, and space exploration. This exploration of research themes will focus on improvements to robot capabilities. A key area focuses on how robotics can provide unified actuation for wheeled locomotion and flight operation. We will look at robotic solutions with vision, language, and action that incorporate intrinsic spatial reasoning. Our discussion will also cover certifiably safe manipulation of deformable linear objects via joint shape and tension prediction, showcasing innovative research methods. One key research theme focuses on improving spatial reasoning in robots. Vision-Language Action, or VLA, models are being enhanced to improve spatial reasoning. To achieve this, an intrinsic spatial reasoning module is integrated, enabling better understanding of spatial relationships. Many VLAs struggle with spatial reasoning, including navigating environments and manipulating objects. Enhancements in this area improves the safety and performance of robots in complex tasks. Deformable object manipulation is another area of focus. Research is directed toward the safe and reliable manipulation of deformable linear objects, or DLOs. Key challenges involve predicting the shape and tension of these objects during manipulation. Applications for this technology include cable routing and surgical sutures. Models are developed to ensure safe trajectory planning when manipulating DLOs. Several key findings have emerged. Zhang and colleagues have presented a unified actuation system for drones capable of both wheeled and flight movement. Zhang et al. Have also significantly improved spatial reasoning capabilities within VLA models. Additionally, they have presented a prediction framework for the safe manipulation of DLOs. These advancements are paving the way for more versatile robotic applications across multiple fields. Diverse methodologies are employed in robotics research. Deep learning is a dominant technique, particularly for perception, planning, and control tasks. This involves using neural networks to learn complex patterns from data. Physics-based modeling simulates robotic dynamics and environment interactions to aid in design and control. Trajectory optimization is also utilized for planning safe and efficient robot movements. The combination of these methods yields significant improvements in robotics. Let's take a closer look at the selected research paper by Zhang et al., focusing on safe DLO manipulation. This research presents a certifiably safe method for manipulating deformable objects. The prediction of shape and tension in DLOs ensures safety and reliability during manipulation. This has significant implications for manufacturing, healthcare, and construction. The research includes successful simulations and real-world experiments validating their approach. Next, we will discuss the research paper by Zhang et al. That focuses on spatial reasoning. Their Inspire VLA model improves spatial reasoning capabilities in robots. This is achieved by integrating a dedicated spatial reasoning module into the VLA architecture. The paper demonstrates superior performance in object navigation tasks. Ultimately, this enhances a robot's understanding of spatial instructions and its ability to perform spatial tasks. The Unified Drone by Tang et al. Is another focal point. This design features a unified drone with both wheels and propellers. This combination enables seamless transitions between flight and ground modes of operation. Experimental results have demonstrated high energy efficiency compared to traditional drones. This technology has the potential for a wide range of applications including inspection and surveillance. Several key directions for the future of robotics have been identified. Overcoming the sim-to-real gap is crucial for transferring simulated solutions to real-world applications. Improving perception systems to ensure robustness in challenging environments is also essential. Continued exploration of unified actuation designs, such as the drone we just discussed, will expand robotic capabilities. Finally, the development of safe and ethical AI for robotics is paramount. This AI synthesis and review has been created using AI tools, specifically GPT with Google's Gemini 2.0 Flash model, as well as Google's TTS synthesis and image generation capabilities. The content has been reviewed by a human expert to ensure accuracy and coherence. However, it is important to acknowledge the potential for oversights, despite expert review. Full references are provided for all source materials used in this synthesis. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.